Have you ever spent literally years working in an industry, totally surrounded by brilliant people, only to suddenly realize you completely misunderstood the foundation of what everyone actually does? I recently came across this deeply relatable quote from a tech professional who admitted, only at age 30 did I understand the true difference between an engineer and a scientist. And frankly, they really aren't alone here. You can go through school, college, and even years of working in software or tech and still kind of blur the lines between these fundamental career paths.
It sounds like such a basic question, right? What is the true difference between a scientist and an engineer? But if you pause and really try to define it, the boundaries can get blurry very fast. I mean, do they just use different math? Is one just, more practical than the other? Well, the answer is so much more profound than that, and understanding it completely changes how you view the modern world and the technology we all use every single day.
Okay, let's dive right into this. Today's explainer is all about the professional hierarchy of science and engineering. We're going to strip away the confusing jargon and look at the actual engines of human progress.
Here's our roadmap for today. We'll be looking at the professional hierarchy, breaking down the 7 parent roles, diving deep into the scientist versus the engineer, exploring how they work together, and finally locking it all in with some real-world tech examples.
All right, Section 1, the professional hierarchy. Parent roles versus specializations.
Look, before we can really understand these roles, we've got to strip away the noise. If you look at any tech company today, you're hit with an absolute alphabet soup of job titles, right? Applied physicist, DevOps engineer, front-end developer. It's enough to make your head spin. But underneath all of that complexity, there are actually very few fundamental parent roles.
Moving on to Section 2, the 7 parent roles. These are the core tech pillars. So, there are exactly 7 parent roles, and what truly separates them isn't their fancy degrees. It's actually the one main question that drives their daily work. The scientist asks, why does it happen? The engineer asks, how can we build it? The developer asks, how do we implement it? The technician asks, how do we fix and operate it? The systems engineer asks, how do we run it reliably? Production asks, how do we make millions of these? And management asks, how do we organize everyone?
Now, because each of these roles has a totally different mindset, they obviously require completely different software toolkits to get the job done. Think about it. A scientist discovering atomic laws, they're going to live in MATLAB, Python, or Quantum ESSO. But an engineer designing a physical solution, they'll use simulation software like COMSOL, ANSYS, or HFSS. A developer pretty much lives in VS Code or Git. And meanwhile, management coordinates this whole shebang using Jira, SAP, and Power BI. The tool always follows the core question of the role.
Okay, Section 3, scientist versus engineer, the two titans.
Now, what's really interesting about this is when we zoom in from that macro view down to our 2 most foundational pillars, we find a massive, fundamental, philosophical divide between their mindsets. The scientist looks at the universe and simply asks, why does this happen? Their ultimate goal is to discover. But the engineer? They look at a practical problem and ask, how can we make this work? Their goal is to design.
And because their goals are so totally different, their constraints are entirely different too. A scientist is primarily constrained by scientific validity and evidence. They are out there seeking the absolute truth of nature, constantly testing hypotheses through experiments. But an engineer is heavily constrained by reality. They have to worry about cost, time, safety, available materials, and even government regulations. An engineer runs experiments not just to discover knowledge, but to verify that their design performs safely under real-world budgets and physical constraints.
So, when we look at the ultimate end result of all their labor, we get this beautiful contrast. The scientist expands human knowledge. Their output is scientific theories, laws, models, and research papers. The engineer, on the other hand, expands human capability through technology. Their output is tangible: products, machines, software, and physical structures. Basically, science gives us the understanding of reality, while engineering actually transforms that reality.
Let's move to Section 4, how they work together, the symbiotic relationship.
Let's be clear, this isn't some sort of rivalry, it's a pipeline. Let's see how this builds, right from a raw discovery all the way to a mass-produced solution in 4 distinct steps. Step 1, observation and research. The scientist notices a phenomenon, asks questions, and studies the underlying principles. Step 2, theory development. The scientist creates mathematical models, laws, and explanations for what they just found. And honestly here, their job is largely done. Step 3, prototype. Now the engineer steps in, learns those discovered principles, and converts those theories into physical designs to build a working prototype. Step 4, production. Finally, the engineer verifies the safety and cost and then actually manufactures and deploys the solution for the public.
To kind of ground this theory in a historical anecdote, just think about Isaac Newton. I mean, he was the ultimate scientist here. He studied reality and discovered the laws of motion and gravity. He literally expanded human knowledge. But Newton didn't build a rocket ship. It was the engineers in the centuries after Newton who took those raw mathematical laws and used them to design and build bridges, vehicles, rockets, and satellites. It's like, I discovered a new law of nature, says the scientist. Great, I can use that law to build something useful, says the engineer.
Which brings us to Section 5, Real-World Tech Examples. Let's see this theory in action.
Think about the creation of an airplane. Step 1 completely belongs to the scientist. They're the ones studying airflow, lift, drag, and aerodynamics, eventually developing these incredibly complex equations and models. But obviously, you can't fly in an equation, so the engineer takes over. They use those aerodynamic principles to physically design the wings, engines, and structures, ultimately building and testing safe aircraft prototypes for passengers.
Now let's look at the smartphone in your pocket. A single smartphone requires almost all 7 of the parent roles we discussed earlier. It starts with the scientist doing semiconductor research at the atomic level using tools like VSAP. Then the engineer uses software like Cadence to actually design the physical computer chip based on that research. Next up, the developer writes the Android or iOS software to make it usable for us. And finally, the industrial engineer steps in using manufacturing software like FlexSim to figure out how to produce millions of these devices efficiently in a massive factory.
And hey, even massive infrastructure like 5G networks follows the exact same hierarchy. It begins with a scientist exploring wireless theory and electromagnetism. An engineer then designs the physical 5G antennas using that theory. But an antenna doesn't just install itself, right? So technicians are deployed to physically mount and test the towers. And to make absolutely sure millions of people can stream videos without the network crashing, a systems engineer operates the entire national network to ensure it runs reliably at scale. It literally takes the whole hierarchy to make modern life possible.
And finally, our conclusion, the ultimate distinction.
We covered a lot of ground in this explainer today, but honestly, it all boils down to this, and this brilliantly illustrates the core payoff here. Scientists discover the rules of the game. Engineers use those rules to build the game. The scientist unlocks the deep mysteries of reality, and the engineer steps up to transform that reality to expand human capability.
Which leaves us with one really important final thought. Take a look at your own life and the way your own mind works. Do you constantly find yourself asking, why does this happen? Or are you always thinking, how can we make this work? Based on the questions you ask every single day, which parent role do you naturally fit into? Take a moment to think about that, because you might just unlock a whole new understanding of your own professional path. Thanks for joining me on this explainer, and keep asking those big questions.